Okay, welcome guys to the next topic of Junior Cert Science Chemistry. We're going to be looking at solutions. So this most likely will be part 1 of 2 because it's quite a long slideshow. There's 17 slides. So if it goes to 20 minutes, I'll stop the video. Okay, because 20 minutes is generally long enough for a video to be watching, even, especially because you're going to be pausing it as you go. So as always, guys, pause the video as we go to take down notes. So obviously your heading at this time is solutions, okay? And then take down your learning intention. So what is the learning intention of this topic? All right, so part 1, we'll get done today at least. We will learn the difference between a dilute, a concentrate, and a saturated solution. Okay, so there are 3 new words, 3 new things we're going to discover. Number 2, we will be able to explain the term crystallization and solubility curves. Okay, so you will be able to explain that. Okay, number 3, we will investigate the effects of temperature on solubility. Okay, that'll probably be part 2, but hopefully we'll see. And number 4, we will investigate how to investigate electrical conductivity in various solutions. Okay, that's very badly phrased. Okay, but you get the idea. Okay, we will investigate electrical conductivity. English is failing me. So again, after your learning intentions, take down your key words. So there's quite a lot here. So we 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 new words here: solvent, solute, solution, dilute, concentration, saturated, solubility, suspension, and crystallization. Now, some of those words you've probably heard before. I reckon you've definitely heard of a solution before. You've definitely heard of dilute before. You've definitely heard of concentration before. Okay, and suspension, and the rest maybe not. Okay, so the rest you probably haven't heard of before. So they're probably the 4 you've heard, but you probably, again, not heard them in the scientific context. Okay, so take down all your keywords. And again, the purpose of the keywords, when you're revising, do you understand what all these words mean? Can you explain what all these words are? Okay, then the learning intentions, can you explain all the learning intentions? Okay, so it's not about learning off, it's about understanding. Okay, remember that. Don't try to learn off. There's too much here. Okay, so your first kind of subheading, so we will just simply call it solutions. Okay, so what are solutions? All right, so if we add salt to water and mixed it in, the salt will disappear. Where is the salt? Okay, so if we have salt and water, when you add salt to water or sugar to water, okay, if you add sugar to a cup of tea, where does the sugar go? The sugar seems to disappear, but when you drink it, you can still taste it. You can taste the sugar. Okay, so what has happened to it? Where has it gone? Okay, well, basically what's happening is that, like with salt and water, you don't need to take this down, but salt molecules separated. Okay, so the molecules of salt separate, and then they get stuck in between the water molecules. So they break up and they get stuck in and around the water molecules. Now you will reach a point where if you keep pouring sugar into your tea, it doesn't all dissolve. Eventually it gathers at the bottom of the cup. Now the reason for that is that the gaps in the water molecules are filled. They're all filled with the sugar molecules, and as a result, what's left falls to the bottom because it has nothing to fall into. Okay, but the points I want you to take down are the bottom 3. This one. So what is a solution? A solution is formed when a solid dissolves in a liquid. Okay, so that's what a solution is. A solution is when a solid dissolves in a liquid. Okay? And now look, our keywords, our first 2 keywords here. A solid is called a solute, and a liquid is called a solvent. All right, so a solid is a solute and a liquid is a solvent. All right, so that's a tricky thing to remember. Okay, now I wouldn't lose too much sleep over it. But the reason you kind of need to know this terminology is that sometimes they'll use that terminology in books, in exam papers, in scientific articles. Okay, they won't say the solid was mixed in; they'll say the solute and the solvent. Okay, so that's why it's important to understand the words. Okay, that's the terminology they could use. Okay, in the exams process, or in scientific articles when you're doing your CBAs. Okay. All right, so. Move it on there. So a solute and a solvent. Okay, so let's discuss these a little bit more. That's your next subheading. Okay, so what is a solute? Well, a more correct term, it's a solid, but basically it's a solid that dissolves in a solvent. So a solute is something that dissolves in a solvent. So a solid that dissolves in a liquid. All right, so a solute is something that dissolves in a solvent. Now the example I have here is you have coffee. So coffee beans, they're a solute. They get dissolved into the solvent, okay, and they form a solution, which is coffee. Okay, so you have instant, now this is obviously instant coffee. You put that into your cup, you pour hot water in. Your solute is the coffee, your solvent is the water, and when you mix it together, you get a solution, which is coffee. Okay, so then look at this down here. Another way to explain a solution. So we already said what a solution is. It's formed of solid dissolved in liquid, but another way. Okay, you could describe it. Let's take this down. Just take the first and the last point. A solution is a mixture of a solute and a solvent. Okay, that's another way to think of it. Now, what do we call a cloudy solution? Okay, so same heading, solute, solvent. Don't worry about that. Okay, but what do we call a cloudy solution? Okay, so if we mix, don't take this down, I'm just going to read it out, okay? If we mix a solute and a solvent, we can end up with a mixture that's not clear, but cloudy. Why does this happen? So basically, if you have mud and water, you mix mud and water together and you stir it around, okay? The mud doesn't dissolve in, it gets all just cloudy and everything, okay? So what's happening, okay? Well, what happens is the particles of the solute are not separated between the liquid particles. Instead, they are what's called suspended, okay? They are suspended. So all I want you to take down here is the last point. Suspension is a mixture in which small solid or liquid particles are suspended in the liquid. Okay? So basically, suspension is when you mix two things, generally a solute, and they get it and they get churned up, okay? And they get suspended one in the other. Okay? So suspension is what occurs. Alright? That's what suspension is. Now we have two keywords ticked off. Okay. So now we're moving on to the next keyword. So let's look at our keywords here. Solvent, solute, solution, suspension. You see, so we've got a few already ticked off. Okay, and our learning intentions, we haven't got there yet. Okay, but we're getting there. Now, concentration and dilute. Okay, so now we're on to our next two keywords. A bottle of Ribena has dilute to taste written on the bottle. But what exactly does this mean? Okay. This means we add water to the solvent, okay? So Ribena, the Ribena drink, the concentrated Ribena that you have, is what we call a concentrate, okay? So if you ever see fruit juice from concentrate, it basically just means it's this kind of stuff, okay? So take on this point here, a concentrated solution is one where there is a lot of solute and only a little solvent, okay? So concentrate. Okay, a concentrated solution is one where there's a lot of solute and only a little solvent. So the more concentrated something is, the more solute there is, the more solid there is in it. Okay? And then, of course, again, you can watch that video there. It's a short animation, actually. It's an animation showing mixing bad liquid, making it acid or concentrated or dilute. All right, so concentrate and dilute solutions, okay? We can make solutions more concentrated by adding more of a solute or evaporating off some of the solvent. So what would be a dilute then? So if a concentrate, so Newton's law, every reaction is an equal but opposite reaction. So if a concentrate is one where there's a lot of solute and only a little solvent, okay, then a dilute has to be the opposite. And a dilute is simply that, where there is a lot of solvent and only a little solute. So take that down as well. Okay, so a concentrate, a lot of solvent, or a lot of solute and very little solvent, and a dilute, a lot of solvent and only a little solute. That's the way to think of it. They're the opposites of each other. If one is one way, the other has to be the opposite. Okay. Now, no time we on. Right, we're on. Okay, we're making good progress. We're on just over 9 minutes. So, back to our keywords. Dilute, concentrate. What do we have here? Between a diluted, concentrate, and a saturated solution. So we've dilute, concentrate, we're on to saturated solution, you see? So we're slowly getting there. We're getting through these. So a saturated solution, okay? If we add sugar to tea, it gets dissolved in the tea. What happens if we add too much sugar? Okay? It gathers in the bottom, as I said earlier, okay? Well, that actually has a word. That's saturated. So take this down. A saturated solution is one where no more solute will be dissolved in the solvent. Okay, so a saturated solution is basically you've added so much, all the gaps in the water molecules are full, or not water, but the solution. Okay, all right, or the solvent. Sorry, yeah, I keep saying, I keep getting mixed up myself. You see, so the solvent, the gaps in the solvent are all filled. Okay, And therefore the solute, the solid, can't go anywhere else, so it just drops to the bottom, okay? Now, the second point I want you to take down, a saturated solution is one which contains as much dissolved solute as possible at a given temperature is key, at a given temperature, okay? So a saturated solution is one which contains as much dissolved solute as possible at a given temperature. And that's very, very important to say that, okay? So that's all I want you to take down there. And then the last point there, an unsaturated solution is a solution which is not saturated. That's fairly, I only put that in because that was a question somebody asked before. What would you call it if it's not saturated? Well, it'd be unsaturated, okay? So what we have here is a sponge. When you have something that's saturated, okay, that's why we often say if somebody's really, really wet, we say, God, you're saturated, okay? And basically, you're drenched, you're wet, okay? So in the bottom jar here, the solution is saturated, all right? And what's happening is that this is an experiment we usually do with copper sulfate crystals. You put copper sulfate in, but and eventually you'll see it'll gather in the bottom. And then what you do is you heat it up. And when you heat it up, this all gets dissolved back into the water, okay? And we'll explain what happens now, okay? So we go back to our done. This entire learning attention is gone. Okay, so we're almost there. See that? So the key words are pretty much covered, and the learning intentions are almost there. We got one down. Okay. Take down your heading. Okay, to investigate the solubility of a variety of substances in water and the effects of temperature on solubility. Okay, now usually what I do here is I get you to go away and write up an experiment, investigate how would you test this experiment. Okay, so what I would advise is in your notes copy. Yeah, leave it. Yeah. Leave that heading now. We'll come back to this. So that's your subheading because the next few notes will all tie in with this. So that's your heading. To investigate the solubility of a variety of substances. So what you have here, right, is solubility, grams per 100 grams of water. And what they have is that they put in their solution, the copper sulfate crystals, and they could only get 30 grams in. Okay? 30 grams, and it was saturated. In other words, particles were gathering on the bottom. So they started to heat it up. And at 20 degrees, they realized that they could get in another, 9 grams, okay? And when they got to 40, they got in another 9, you see? So the hotter they made it, okay? So as the temperature increased, they were able to get more and more and more of the solution in. They were able to get more and more and more of the copper sulfate into it, okay? To desaturate it even further, okay? So underneath your heading, just take down this. In general, the hotter the solvent is, the more solute it will dissolve. So the hotter the solvent is, the more solute it will dissolve. Okay, hotter. So think about why would that be? What's happening there? What could possibly be happening there? All right. So what do we mean by solubility? Okay. All right. So this is all still under this heading. Okay. All right. So the solubility of a substance is the mass of it, obviously in grams, that will be dissolved in 100 grams of solvent at a fixed temperature. Okay. The solubility curve is a graph showing how the solubility of a substance varies with temperature. Okay? So the solubility of a substance is the mass of it that will dissolve in 100 grams of solvent at a fixed temperature. Right? And the solubility curve is a graph showing how solubility of a substance varies with temperature. All right? So in other words, how we increase the temperature, we increase the solubility. You see? That's what it is. Okay? And the mass of it, that will dissolve in 100 grams of water. So how many grams will dissolve in 100 grams of water as we go through it? And that's it. Okay? That's it. They're your solubilities. Okay? Now, again, usually I do have, in the class, we usually stop it there and get you to investigate. That's usually what I do. But obviously, for now, that will most likely be, we'll see. I'll probably give you that as an assignment due to the online learning. But hold tight for the time being, okay? I'll tell you what to do on the Teams page. All right. So that's solubility. All right. So we're solubility. Explain term crystallization. Right. So we solubility curves there. Investigate the effects of temperature and solubility. The hotter something is, the more soluble it gets, the more it dissolves. Okay, so we got to look at crystallization next. All right, so we're at 15 minutes. Let me see. Okay, so we're at 15 minutes. We'll keep going because there's not much left. We just do crystals 1, 2, 3, 4. So there's 4 slides. Yeah, we'll keep going. All right, so we'll go over 20 minutes, but that's fine. 20 minutes it's there is no 2 parts here. Okay. Right, so your heading here is simply just crystals. All right. So what are crystals? Crystalline solids have a definitive shape because the atoms in the crystals are in a regular pattern. So take that down. Key here, crystals are in a regular pattern. The atoms. So the atoms in the crystal are in a regular pattern. They have a regular shape and a regular pattern. Okay, it's not chaotic. And examples, guys, are the easiest ones to remember: sugar and salt. And then, of course, actual crystals like diamonds. And even ice. Ice forms crystals. Even water. Water, when it freezes, forms crystals, ice crystals. Okay? Other solids are considered non-crystalline. In other words, they are considered non-crystals. Okay? All right, so take down those 3. All right. Now, for the examples, you only need to know 2 examples, really, guys. Sugar, salt is fine. Diamonds, and if you know of another crystal, technically that's a crystal as well. So any crystal you give will work. Okay? Now, for this, I want you to draw this in. So take down that heading. This is the experiment. To grow crystals using copper sulfate solution. And again, like before, when you're drawing your... delete that. And delete that. And delete that. Right, so when you're drawing this, keep it simple. Okay, nice and simple. All right. So for example, your hot plate is just something like that. Okay, with a little stove on the top. And then your beaker is a terrible beaker. And I'll draw with the actual pen this time. You see? Nice and simple. And then we have our glass rod for stirring. And again, I'm drawing this freehand on a tablet, so that's why it's looking very terrible. And then, of course, your spatula with the powder on it. Okay, and there you go. And then label it. That's it. That's all you have to do. Nice, simple diagram like that. Okay? Keep it simple, keep it basic, all right? Simple shapes, squares, rectangles, circles. That's all you have to do, guys, all right? Get rid of that. Okay, so squares, rectangles, circles. All right, so draw that in and label it. Okay, to grow crystals using copper sulfate. All right, now again, don't worry about the methodology. Usually I give that as it's there anyway in your lab books that you got at the very start of the year. Okay, and pause the video there and watch that YouTube video which goes through the experiment itself. Okay, right, so if you've that drawn in, you take this down. That's important. It's kind of your subheading, if you will. All right. Does the rate at which we cool the solution affect the crystals? Does the rate at which we cool the solution affect the crystals? So what you're doing with this experiment, as you saw from the video, is you basically heat up this solution and keep adding more and more and more copper sulfate. Okay. And eventually create a saturated solution. You then pour it out into dishes and you leave them cool down. Okay. So if we cool them slowly, so take that, you're going to have to take on all these points actually because they explain the experiment. If we cool them slowly, that word shouldn't be there. Larger crystals will form. Why does this happen? Okay, well, if we speed up the cooling process, it does not give the solution time to form larger crystals. Okay, so if we force it to cool down really fast, okay, we don't give the bonds time to form. Okay, so they don't get time to form their large crystalline shapes. Instead, they're forced to form their smaller shapes, any old bonds really, if you will. Okay. Ignore the next point, but take on the last one here. The process of forming crystals of a compound by cooling a saturated solution is crystallization. All right? So forming crystals by cooling down a saturated solution is our crystallization. That's what crystallization is. Okay? We cool down a saturated solution. And that's it. Now the last, as we can see here, go back up to our keywords. Crystallization is now done as well. Okay, all right, we just did it there. We can explain the term crystallization. The last thing, electrical conductivity. You see, so we've now got everything done. Okay, so electrical conductivity. All right, so that's your subheading. So some substances do not conduct electricity when in a solid state. Why does this happen? So this was a kind of an exam question. I think it came up as part of an electricity question, actually. So see, all the sciences interlink. Electricity is physics, but this was kind of came up, right? And here's why. The particles in some crystals are fixed in place and therefore won't carry the charge. Okay? So some crystals, they don't move. The particles won't move. They're stuck in place. Okay? So once they get the electrical charge, they won't pass it on. They'll keep it. All right? So as a result, the conductivity won't occur. All right? However, when in water, the particles are free to move. Thus, they will take the charge with them. Okay? So when they're in water, they are free to move around. And then they'll take the charge with them. So then they'll take the heat or the electricity and move with that charge with them. For example, if you have salt and you put a wire into salt, okay, electricity into salt, nothing will happen. If you put electricity into water, water is a very poor conductor of electricity. However, if you mix salt and water together, all of a sudden it runs very strong, very powerfully. Okay, so that's how you could show it there. Actually, I just gave it away the last bit. That's it. There you go. That's how we would do it. What I have here at the end, guys, is this is the first one. So in your own time, see if can you answer it. So pause the video there. The diagrams show 3 solutions of copper sulfate. Starting with a dilute solution, state how to make it more concentrated. And then how do you know when a saturated solution has been produced? Okay, that's the first one. And of course your answer. And then the second one, again, pause the video, see can you answer it, and then check the answer. The growth of crystals can be investigated using either aluminum or copper sulfate. We use copper sulfate. The experimental procedure is similar in each case. When you carried out the investigation, the first thing you had to do was make up a hot saturated solution of copper sulfate. Name the solvent in which the copper sulfate was dissolved. How was the sulfate heated? What needed to be done to the hot saturated solution so the crystals would form? Other than the piece of equipment used in the hot heat solution, name another piece of equipment. So easy enough one, actually. And they're kind of basically your answers. That's it. Right, guys. So as always, if you have any questions, put them into the comment section below or in the Teams page, or you can hold off until the live class. All right, best of luck.